All right, so for this video, we're going to work with Hess's law of summation. I like to think of this particular way to calculate delta H as like a puzzle. Most students don't like it because you do have to treat it like a puzzle, but it's really not that bad. Hess's law of summation is what this one is called. So basically, how I know to use Hess's law of summation is they will always give me some sort of goal equation. So this is the equation that I'm trying to figure out the delta H for. In addition to your goal equation, I am also given several other different types of equations with delta H values. Basically, what you have to do here is you have to use all of these equations, rearrange them, and some reactions you might have to flip, some reactions you might have to multiply or something. And whatever I do to this reaction here, I have to also manipulate my delta H to match that. So I'm trying to combine these equations here to make my goal equation. And once I'm combine all of these reactions here, I'm then going to combine my delta H values, and that will be my delta H value for the entire reaction as well. So when you are working with Hess's law of summation, the very first thing that I always look at is I say, all right, this is the stuff that I want in my reactant side. This is the stuff I want in my reactants or my product side, and this is the stuff I want in my product side as well. So I always make sure that this stuff is on the correct side. So I locate where H3BO3 is in this system of equations. So H3BO3 is present right here. Because it is in the reactant side and I want it in the reactant side, I want to keep this reaction where it is. I don't want to flip it or anything. Now I look for B2O3. B2O3 is present right here. This is in the product side, and I want it to be in the product side, so I want to be able to keep that reaction as well. I don't want to flip it or anything. Now I look at water in the liquid form. Well, I have some water in the liquid form here, and I wanted to keep that reaction anyway. I have some water in the liquid form here. I want to keep it that way. But do you see how there's some water in the liquid form on my reactant side? I'm more than likely, it isn't always going to work out this way, but I'm more than likely going to want to flip this reaction to get that on the other side. So let's just push that aside for right now, and let's look at the other stuff. The only three things that we want in my equation is H3BO3, B2O3, and H2O liquid. Well, you notice that we have some stuff like HBO2, H2B4O7 that we do not want in the equation. So somehow we need to eliminate these. Now, in order to eliminate this stuff, I have to have the same amount on both sides of my yield sign. So right now I have HBO2 on my product side. Well, I have more HBO2 on my product side, so I can't eliminate those two. Here I have H2BO4 and H2B407 both on my reactant side. So I want to be able to eliminate these somehow. So what that tells me is that I want to flip this equation so that maybe I can eliminate those things. Now, the rule is, if I flip this equation, I also have to flip my sign for my delta H. So instead of this delta H being negative 11.3, I now am going to make that a positive 11.3. Now, to make things simplistic, what I'm going to do is I'm just going to rewrite this flipped down at the bottom. So you see how I rewrote this middle equation down at the bottom, and I'm just going to mark this out so now I can see what crosses out easier. H2B4O7, I have one on my product side now and one on my reactant side. So what that does is that eliminates H2B4O7 from my reaction completely. Now, when you have things cancel out, I do not have to manipulate delta H. It's just because it cancels out naturally. I also want to get rid of HbO2. Now you see how I have 4 of them in the reactant side here, and I only have 1 in the product side. In order for me to cancel these out, I have to make sure that I have the correct or the same number on both sides. So what I'm going to do to fix that is I'm going to multiply this top reaction by 4. If I multiply that top reaction by 4, that 4 has to distribute to everything here. So now I have 4 H3BO3s, 4 HbO2s, and 4 H2Os. Now that I have 4 of everything, since I multiplied this whole equation by 4, I also have to multiply this delta H value by 4 as well. Remember, whatever I manipulate here, I have to do to my delta H as well. Now I have the same number of HbO2s on both sides, so these guys actually cross out. Now I look to see if there's anything else that's in here that doesn't need to be, and I think everything's good. So now what I'm going to do is I'm going to combine all of these equations. So 4H3BO3 is going to come down. 2B2O3 is going to come down. And I have a total of 4, 5, 6 H2Os. Now, you might be saying to yourself, well, Gullich, that's not the right equation because I only have 2 to 1 to 3 relationship here, and I have a 4 to 2 to 6 relationship here. Basically, this equation right here is double the goal equation that we need. That's okay, because in order to get this total equation to match this goal equation, I have to divide that whole equation by 2, right? Well, what I'm going to do to these delta H's is I'm going to add all of these delta H values up. When I do so, 4 times negative 0.02 plus positive 11.3 plus positive 17.5. When I do that, I get 28.8. Now, that value is for 4 H3BO3 yields 2 B2O3 plus 6 H2O. Well, because I had to divide this whole equation by 2 at the very end to match my goal equation, I'm going to have to do that same exact thing to this total delta H value as well. So 28.8 divided by 2 is equal to a positive 14.4 kilojoules per mole reaction. Because it is a positive value, then that means that it is an endothermic reaction. It is going to absorb energy there. So this approach is known as Hess's law of summation. Now, they do not ask this as often as Hess's law or the other things that we're going to talk about, but they do ask it every now and then. So the things you have to remember is, first, make sure the correct reactants and products are on the correct side. Then you start working on eliminating the things that need to be eliminated. Remember, whatever I manipulate over here, I also have to manipulate the delta H. And at the very end, if you get a double or triple or quadruple the quantity of the reaction that you need, you can always divide it by the number to get it to the goal equation at the very end. And remember to do that for your delta H as well. So I hope this gives you a little bit of insight on doing Hess's law of summation.